Lesson 52 is about chemical mixture problems. Example 52.1 says a pharmacist has one solution that is 10% iodine and another that is 50% iodine. How much of each should he mix together to get 100 milliliters of a mixture that is 20% iodine? So the way we're going to do this problem is we're going to write two equations in two unknowns, and we're going to solve it using elimination. So first of all, you can see the picture here. We have two containers, one with a 50% iodine solution in it, one with a 10% iodine solution in it, and each one is having some amount poured into another container to create a 20% iodine solution. The first equation we're going to write is just going to be about liquid. It's not going to be about iodine. It's not going to care what the iodine is. All it's going to be about is milliliters of liquid being poured. So we're going to pour X milliliters out of this first container and Y milliliters out of this second container. We're going to pour them into the third container, which we want it to end up being 100 milliliters. So our first equation is just going to be X plus Y is 100. This equation is just about milliliters of liquid. We don't know what it is. We don't care what it is. It's just X milliliters of something plus Y milliliters of something else gives us 100 milliliters of something else. So now we're going to write an equation about iodine. This equation is going to be about milliliters of iodine. Well, we know that the X milliliters that are being dumped out of the first bucket is 50% iodine. So 50% of that amount, 50% times that amount is iodine. The stuff we're pouring out of the second bucket, Y milliliters, 10% of that is iodine. So 10% of those milliliters, that's iodine. And then we know that the final bucket, we want it to be 20% iodine. So 20% of that 100 milliliters we're going to end up with is iodine. So we have two equations, we have two unknowns, so we know we can solve it. So the two equations, X plus Y equals 100. And this second equation, when you change the percents to decimals, you're going to have 0.5x plus 0.1y is equal to 0.2 times 100, which is going to be x plus y equals 100. And the second equation is just 0.5x plus 0.1y equals 20. So these are our two equations. The first thing I'm going to do before I do anything else is I'm going to multiply that second equation by 10 in order to get rid of the decimals. So my first equation will be x plus y equals 100, and my second equation is going to be 10 times 0.5x plus 10 times 0.1y is equal to 10 times 20. So my system of equations that I'm going to solve is x plus y equals 100, and then I'll have 5x plus 1y, so just y, is equal to 200. All right, so to solve this, I'm just going to subtract the two equations because the y's both have a coefficient of 1, and if I subtract the two equations, the y's will go away. So x minus 5x is negative 4x. Y minus y is 0. It's gone. 100 minus 200 is negative 100. Divide both sides by negative 4, and you get that x is 25 milliliters. If x is 25 milliliters, x plus y is 100, so y must be 75 milliliters. So my answer would be that I would need 25 milliliters of the 50% solution. And I would need 75 milliliters of the 10% solution. Here's another one. A chemist has one solution that is 10% salt and 90% water, and another solution that is 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt? So in this problem, they tell you about the water in there too. If it's 10% salt, it's 90% something else. And in this case, it's water. The second solution is 2% salt, which means it's 98% water. And it's not important really to know about the water because you're going to write your equations about liquid and about salt. So it's just to kind of give you an idea that you could write an equation about water if you wanted to, but we don't need to, so we're not going to worry about it. All right, so again, we are going to just say we're dumping X milliliters of this in and Y milliliters of this in, and we're going to get 1,400 milliliters for our final solution. So we're going to write an equation about liquid. Don't care about the salt. It's in there, but we don't care. X plus Y is 1,400. Just 1,400 milliliters of stuff being poured from two containers into the third container. That's it. Now we're going to write an equation about the salt. We know that these X milliliters are 10% salt, so that's 10% of X is salt. 2% of Y, those milliliters, is salt. And then 6% of the 1,400 milliliters we end up with is supposed to be salt. We're going to rewrite that salt equation. 10% is 0.1 X, 2% is 0.02 Y, and 6% is 0.06 times 1,400. If I multiply this whole equation through by 100 to get rid of the decimals, I'll have 10x plus 2y is equal to 6 times 1,400. And if I multiply that 6 times 1,400, I am going to get 8,400. So that second equation is 10x plus 2y is equal to 8,400. So my two equations are x plus y is equal to 1,400 and 10x plus 2y is equal to 8,400. This is the system of equations I want to solve. And to do it, I'm going to do it by elimination again. If I multiply the top equation by -2, I will have -2x minus 2y equals -2,800. And my second equation is going to stay the same. 10x plus 2y is equal to 8,400. If I add these two equations together, I am going to have 8x is equal to 5,600. So divide by 8 and I get x equals 700 milliliters. All right, so the total milliliters is 1,400, which means that y is also going to be 700 milliliters. My answer would be 700 milliliters of the 10% solution and the 2% solution.